Okay, so we're going to prove the law of sines, which states that if triangle ABC has lengths AB and C, representing the lengths of the sides opposite the angles with measures A, B, and C, then sine of A over A is equal to sine of B over B, which is equal to sine of C over C. So the way it's described here is how I drew it here. So let's go ahead and start the proof. So what we can do first is we can draw altitude BD. So draw altitude BD from vertex B. So right about here. Let's try to do the best we can. Oh, okay. Well, that's a little crooked, but altitude BD, and let BD, this length, equal H1. So we're going to let this distance here between B and D, this altitude, be height 1, right? So we did that because we have sine trig ratios in there. And of course, with trigonometric ratios, you need right triangles. And in drawing that altitude, we got two right triangles, right? So let's go ahead and look at sine of A. So sine of A, remember sine is opposite over hypotenuse. So this is going to be H1 over C. Multiplying both sides of the equation by C, we get H1 is equal to C sine of A, right? We can do the same thing with sine of C. Sine of C will be opposite H1 over hypotenuse A. So sine of C will be equal to H1 over A. And then multiplying both sides of this equation by A, we get H1 is equal to A sine of C. Now we have this height 1 is equal to C sine A, and this height, the same height 1 is equal to A sine C. So that means C sine A must be equal to A sine C. So this implies that C sine of A is equal to A sine of C. And then dividing both sides of this equation by A times C, we can get the equation we're looking for. Sine of A over A is equal to sine of C over C. So we get sine of A over A is equal to sine of C over C, dropping this altitude and looking at sine of A and sine of C, right? So now what we're going to do is we're going to draw another altitude, and we're going to call it H2. So here's the altitude we're going to draw. Hopefully I do a better job than the first one. Okay, so we're going to label this point here E, and we'll have this altitude here have a length of H2, right? This EC. So let me go ahead and say draw altitude. Make sure CE, right? CE, and let CE equal H2. Okay, so why I did that is see how it creates this little right triangle here, this triangle BEC. So I know this angle here, this whole angle has a measure of B. So if this whole measure has an angle of B, that means this angle here will have a measure of 180 minus B, of course, right? Since this angle plus this angle is 180, right? Because they're a linear pair. So I see that sine of 180 minus B is equal to H2 over A, right? Opposite over hypotenuse. So sine of 180 minus B is H2 over A. All right, and in a previous video, we proved that sine of 180 minus b is the same thing as sine of b. So this implies that sine of b is equal to h2 over a. Now multiplying both sides of the equation by a, we get H2 is equal to sine, oh, I just need to put the A in front first. It'll be A times sine of B. Now, what I can do is I can look at this big right triangle here, right triangle AEC, and I'm going to look at sine of A from this perspective here. So sine of A, right, is going to be H2, opposite of A is H2, over the hypotenuse, and the hypotenuse for right triangle AEC is going to have a length of B, right? So I can see that sine of A is equal to H2 over, remember, sine of A opposite H2 over B. And multiplying both sides of this equation by B, we get H2 is equal to B sine of A. Now, I have H2 is equal to A sine B, and H2 is equal to B sine A. So this implies that B sine of A is equal to A sine of B. And then, dividing both sides of this equation by A times B, we get sine of A over A is equal to sine of B over B. And look at what we've done. We have sine of A over A is equal to sine of C over C, and sine of A over A is equal to sine of B over B. So we can connect them really nice, right? We know that sine of C over C is equal to sine of A over A. So let's go ahead and put that. Sine of C over C is equal to sine of A over A. And sine of A over A is equal to sine of B over B. And of course, to make it look exactly the way we want, right? That means that sine of A over A is equal to sine of B over B, which is equal to sine of C over C. So of course this means sine of A over A is equal to sine of B over B, which is equal to sine of C over C. And that's what we set out to do. That is the law of sines proof.